Who among us can honestly say that they don't need a trebuchet for home defense? Today, we're going to design and build a trebuchet big enough to fling some serious groceries. I'm Shawn Wasserman, and this is Some Assembly Required, brought to you by Engineering.com. I know I said we build a trebuchet big enough to fling me over a pit of molten lava, but Engineering.com's insurance wasn't going to cover that. So instead, we're going to throw some high-impact fruit. Trebuchets are simple machines. You just load weight on the short end of the arm, and leverage generates the potential force you need to throw the projectile. To build a machine big enough to throw a pumpkin, we had to go back to physics. The pumpkin weighs about 10 pounds. We want it to go about 50 feet to be sure of a splashy impact. In a perfect world, the maximum range would be twice the height of the counterweight times the ratio of its mass over the projectile mass. I have 100 pounds of weights here in the shop, so if we assume an efficiency of about 50%, we need to lift our counterweights at least 5 feet. To maximize the distance, we have to make the long arm as big as we can, say about 4 feet. By extending the arm and ensuring the 5-foot drop, our short arm is now about 32 inches. Now we can add a couple of rotational actuators to the diagram to see what it will look like when it moves. Not bad. All right, let's get building. I'm going to build this at a 2-inch stock so that everything is easy to source from the lumber yard. There aren't any unusual tools here that you're going to be using, just a circular saw and some hand tools. Here's the bill of materials. I'll post it in text at the bottom of the video so you don't have to take notes. The entire cost was less than $50. I started by cutting all the 2x4s to size. We need 6 short ones and 2 that are 74.5 inches long for the base. Next, let's attach the side supports. They're going to be key because they're going to hold a lot of force. I did a nice job cutting the angles on the support arms using a miter saw, but you could get away with using a circular saw if you're careful. The arm is very simple. It's just a few 2x4s screwed together. And we attach the rods for the weights and the pivot points by drilling some holes. To make it swing freely, I reduce the friction by adding these plastic bearings. We attach this together and voila, it's taller than me. Glad to see the arms moving freely as designed. When we add weight to that end and hold this one down, we'll have our force ready for release. Now let's design the winch loading mechanism. Why? Because I have to have this winch in the shop and because it'd be awesome. That's why. And no, I didn't include the winch when I said the cost would be under $50. Now to really increase the range and leverage of this weapon, I'm going to add the string and canvas bag. Let's take a look at this in our animation software. I've modeled an actuator to represent the winch pulling down the lever arm. To make the trigger, I've attached the winch to a hitch pin. I tied a longer string to the latch so I could stand back. Safety first. Let's go outside and try this thing out. Thanks to Autodesk for sponsoring this episode. We've been using the free app ForceEffect Motion to do the analysis on the trebuchet. You can find the app in the Android Marketplace, or in iTunes, or by following the links below this video. If you like this video, please give us a like on YouTube, Facebook, or Engineering.com. Thank you to everyone who gave us all these wonderful suggestions for future videos. That's it for this week. Join us next time when we simulate a wind tunnel within the garage. Seriously!